Welcome to Chapter 9 in the exciting world of UV texture coordinates and texturing. So what I'm going to do is start making UVs for all the surfaces in here. So the way I'm doing this is I'm actually going to use UV master just to get a very rough, simple unwrap of the pieces, and then I'm going to continue the UV texturing process in Maya. I'm just going to give you a very general overview of my process. So in the Z plugin palette, you'll find UV Master, and the first step is generally to work on a clone of your object. So I pressed on the Work on Clone button, and this just works on a copy of the original head surface, but it has no subdivisions. Since I want this to be symmetrical, I've turned on symmetry, and then just press the Unwrap button. It'll go through the process of unwrapping, and then if you press the Flatten button, you get to see a flattened display of the UVs. So then I'll press Unflatten and copy UVs, go back to my original model, my original head subtool, expand the UV master and press paste UVs, and that pastes the UVs into my surface. You can sort of see what the object looks like in a flattened view of your regular model by expanding UV map and pressing the morph UV button. This is a good way to check the UVs. Now what I'm going to do is I'm going to export all of these guys at the lowest subdivision level, so all the subtools. And to do this quickly, I'm going to use the multi-map exporter plugin. So in the Z plugin palette, expand multi-map exporter. These are the options or what you want to export. Right now I just want to export the mesh. So I'm turning on export mesh, turning on the subtools so that it creates exports a mesh for each subtool. So in the export options, I'm going to expand mesh export. This is extremely important. Turn group off. This can rearrange your point order of your meshes, so when you bring in the UVs back into ZBrush, it'll screw everything up. So if you turn group off, then the point order is maintained and everything should work smoothly between the two applications. But make sure you turn this off. I've turned on merge UVs, although this sometimes doesn't always work as it's supposed to. And I've turned on quad to make sure that everything is exported as a quad that is a quad. So those are my options. And also set this to subdivision level 1 so that every subtool is exported at subdivision level 1. So that being said, set all the options and then press create all maps, and it goes through the process of exporting everything. Okay, so I have all the surfaces here in Maya, and I'm going to spend some time in Maya working on the UVs, optimizing them, and fixing any problems. Now there are a couple issues when you export models from ZBrush that you should be aware of. You should always double check when you're in Maya. So I created a stinger here, and just very quickly out of some Z-spheres in ZBrush. I used UV Master again to create the UV texture coordinates, and I've imported it as an OBJ. There are two main issues you have to look out for when using this workflow. One is flipped normals, and the other is that the UVs are not always properly merged together. So if you turn on shaded display in the UV texture editor, you can see it shades the UV shells either red or blue depending on their normal direction. And you want to sort of try and make sure that these are consistent within Maya and also among the UV shells, at least as much as possible. So consistency is the most important thing. You want to make sure they're all blue or they're all red. Either way, just be consistent. Also check for overlapping UVs. Those can cause serious issues when you're rendering. I do think that, for every 10 minutes you spend creating decent UV texture coordinates, you probably save yourself an hour of trying to figure out why your render's not working later on. So you might as well spend some time, do UVs well, and you'll save yourself some headaches. Currently I still use UV texture coordinates in my workflow, and that's because I rely on Photoshop a lot to paint my texture maps. So I haven't switched over to using PTEX quite yet. Probably at some point in the future I will. But at the moment I still find UV texture coordinates, even though it's fairly old school, a very useful way to go about doing texturing. So back to the technical aspects of texture mapping in Maya. So I'm going to select my UVs here and do polygon flip. That flips them, so now they're all blue, which is preferable. The other problem that you'll find if I select a few of these UVs and do Control right mouse click to shell, you can see that the shell are not connected. They're sort of stuck in these arbitrary bits here. So to fix this, I'll select all of the UVs and do polygon merge UVs. ZBrush is supposed to merge these when it exports, but every once in a while it doesn't. So I usually check and make sure. So now I'm going to shrink these guys down. They don't need 4K, and place them on one of the other maps. So let's take a look at how I've set some of these guys up. I've got these in groups organized by how I think I want to apply my texture maps. So I'm thinking of doing 4K texture maps. So I'm going to have a map for the thorax, a map for the head, antenna, eyes, and mouth parts, a 4K map for the abdomen and the legs, and a 4K map for the wings. That's where I want to put a lot of my texture space. And the stinger, I think I'm going to stick in the same map as the thorax, just because I have some extra space there. If I take a look at all of these, here are my edited UV texture coordinates for the various maps. So head UV, you can see I've actually maximized the space. Let me switch to texture view. I applied just a simple shader with a checkerboard just as a way to visualize the UVs. But for the head, I've biased the texture space for the head and the eyes and the mandibles, and the antenna are taking up. I shrunk the UVs down a little bit because they're mostly, the antenna are going to be covered with hair, so they're not quite as important as the other parts. And I'm sort of, making my decisions based on what's going to be most visible in the final render, because I really want to make sure that I preserve as much texture space as possible for those parts of the model that I really want to shine. So for the mouth parts, which are going to be largely covered in hair, you can see, let me rename these guys. You can see that they're slightly smaller, so they have less texture space devoted to them than the rest. And for the abdomen, it's a similar situation, but since the abdomen, let's take a look at it here. The abdomen is made up of shells with a bit of thickness, so that means there is an interior, faces on the interior of the surface as well as the exterior. And I don't want to waste texture space on those parts that aren't going to be seen. So I'm going to do this with the thorax in just a moment, but what I've done here is split the UV shell, so the exterior parts get much more texture space than the interior parts. And it's the same for each one of these. So you can see the same deal with all of these guys. So here are the final UV coordinates for all the surfaces in the insect. So thorax surfaces, head, mouth parts, antennae. This is the abdomen and the legs, and this is the wings. So the next part of this process involves exporting these guys out to back into ZBrush, so I can create my texture maps, displacement bump, and all that kind of stuff. Okay, in ZBrush, there's a few steps you need to take to successfully import UVs into ZBrush. It doesn't matter if you create the UVs in another program other than Maya, whether it's Hedis UV Layout or Modo or whatever you like to use. The process for importing is pretty much the same. You notice I'm not using GoZ, I'm doing everything kind of manually, which involves a few more steps but allows me to have sort of greater control over what's going on. Again, that's just a personal style of working. Some people like to use GoZ. I'm a little bit old school when it comes to this kind of thing. So the first thing I'm going to do is let's take a look at just the thorax. I'll just do one of these as an example, but I use the same method for each subtool. So I'll turn on Solo. And put this down at subdivision level 1. I'm going to go down to morph target, delete any existing morph targets, and store a new morph target. Once that is stored, I'll go to the top, choose import, and I called it thorax UV. So I should not see any warning messages because I haven't changed the point order or altered the geometry in Maya. All I've done is created new UVs, so it should be able to bring them in. This is why it's important to store a morph target to make sure that they come in properly. So I don't see any change in the surface. So if I subdivide it, I want to make sure that nothing explodes. If points go off in random directions or something looks really funky, it's because the point order has changed. You need to go back and re-export from, well, actually you probably need to go back a few steps, because a lot of times it's actually exporting from ZBrush that causes those problems. Okay, so nothing's exploding, so this looks like it's in good shape. Let's go down and check out the UVs. I'm going to go into Texture Map, and this is a step that I always perform when I import UVs. It's very important. Under Create, I'm going to press New from UV Check, and this is going to create a gray texture. And if you take a look at the texture, if there are any red spots, that means that's a place where the UVs are overlapping, or there's some other problem that needs to be fixed. So it's a good idea to check the UVs when you bring them into ZBrush. But you can see this is the new UV arrangement that I have for this model. So I just need to repeat this process for all the other subtools. So now I'm ready to export my texture maps from ZBrush. I generally use ZBrush as a starting place for texture maps. So the downside of polypainting is that, it's a fun process, it's enjoyable. However, in order to get a true high resolution map, you have to subdivide your model a lot of time. You have to have 10, 15 million polygons just to really generate an accurate 4K map. So I generally don't like to do that, because it slows down the process in ZBrush a lot. So what I do is I create my polypaint in ZBrush, convert it to a 4K texture, and then use Photoshop to upres it and to sort of finish the texture off. And same with the other maps, whether it's displacement or normal or bump maps or whatever I create in ZBrush. They're generally just a starting place, and I finish it usually in Photoshop. So the maps that I'm going to export, I'm going to use the multi-map exporter, because it'll allow me to generate maps for all the subtools at the same time in one go. So I'm going to use a displacement map, a normal map, texture from polypaint, ambient occlusion, and cavity. And the ambient occlusion and cavity I'm just going to use as helper maps in Photoshop as I work on the textures. I haven't decided if I'm going to use normal maps or not. I may stick to just regular bump maps. Depends whatever looks good. So I've got my maps selected. I have subtools turned on so that it does it for every single subtool. I'm going to turn on merge maps so that the maps are in the right texture space. Choose my resolution, which is going to be 4K, 4096 by 4096. Maybe I'll pump my map border up to 5 pixels, so that just adds a little edge between each shell. And most importantly, I'm going to turn on Flip V, and this ensures that all the texture maps are flipped correctly, so that when I bring them into Maya, I don't have to flip them again, because ZBrush and Maya see UV texture space sort of reverse vertically. In the export options, for file names, I'm going to stick with the default because I'm used to them, but these are basically the extensions to let you know which map is which. And I'm going to stick to TIFFs. UV tile ID format. If you notice, my UV maps go beyond the 0 or the 1-to-1 space or 0-to-1 space, so this should add an indicator just so I can keep track of which texture map is going where, and that's appended to the file name. In the displacement maps, the settings I'm going to use, I'm going to create a displacement map from subdivision level 1. I'll turn on adaptive and smooth UV. I'm going to stick to 16-bit displacement maps. A lot of people will use 32-bit maps, but what I like to do is I want to see what I can get away with in terms of using 16-bit displacement maps. And then if I decide based on the camera view or the angle or zoom in or whatever, then I need more, then I will go back and generate a 32-bit displacement map. But a lot of times 16-bit works just fine. So I'm going to stick to 16-bit. Since I'm going to be rendering this in Maya, I'll have 3 channels. DP subpix I usually set up to 2. I'm going to set the mid value to 0.5, which means that 50% gray is no displacement, lighter colors displace out, darker colors displace in. I prefer this setting because it allows me to edit the displacement maps in Photoshop. If I set this to 0, it'll be correct for Maya, but if I need to edit the displacement map in Photoshop, I can't really paint in negative colors. So I'll set this to 0.5. It might mean that I need to make an expression in Maya later on to correct for that, but that's okay. If that happens, it's really not that big a deal. I'll leave 32 displacement off. I'm going to leave scale at 1, intensity at 0. So, and I'll just leave those as is. I'm not doing a vector displacement map. For normal map, I'm going to leave this at subdivision level 1, turn on tangent, and smooth UV. Those are the only settings I'm going to use. For ambient occlusion map, I usually go with the default settings. Maybe I'll up the scan distance to, let's say 1, just to make sure it's fairly intense. Maybe I'll put the density up to 1.5. Let's see how that looks. Cavity map, I'm going to leave these as leave cavity maps at their default settings, and that's all I need to do to set those up. And now that I'm ready to create the maps, I'm going to press the Create All Maps button. This might take a little while, so I'll pause the recording here and come back and take a look at the maps. So all the maps have been exported from ZBrush, and I brought them into Photoshop, and I'm going to spend a fair amount of time in Photoshop correcting some of the issues, up-resing the texture maps, making improvements, and also adding more maps as I see fit. So I'm sort of using Photoshop as a go-between between ZBrush and Maya. So this is where I'm going to do most of my texturing work. And I'm keeping all of my texture maps in a single Photoshop file, which makes my life a lot easier. It's a technique that I picked up from Mark de Decker, who's a good friend of mine and a really excellent texture artist. So I've got these things organized. Organization is the key to making a nice smooth process, and especially if you have to go back and fix things later. And I've organized these guys into layer groups, and each layer group is named after the texture space that I created in Maya. So the first group, U0, V0, is all of the maps for the thorax. The layer group U1, V0 is all the maps for the head. U2, V0 are the abdomen and leg texture maps. And U3, V0 are the texture maps for the wings. So let's talk about some of the issues that I want to use Photoshop to correct. The first is something I mentioned before when I was talking about resolution of polypaint and the problems with polypainting in ZBrush. The main issue is that when you want to create a genuine 4K map, you have to be aware that the resolution of the mesh, the number of polygons in the mesh, has a direct impact on the resolution of the texture map, and this is because you're applying colors, RGB values, directly to the polygons of the ZBrush mesh. So if I take a look here at this guy, and I'll zoom in until we can see actual pixels. So here's a good here's a good example. You can see that a single pixel in ZBrush actually occupies anywhere from 2 to 4 pixels here in Photoshop. So it's not actually a true 4K map. It's a little bit lower resolution. One solution, of course, is to subdivide the heck out of the model in ZBrush, but I do find that the problem with this approach is that it can start to bog ZBrush down. If every subtool starts to get around 10 million polygons, your life is going to start to be a little bit on the miserable side. And also, I'm not a huge fan of HD geometry workflow in ZBrush, so I find Photoshop a lot faster, so that's where I prefer to do it. If you're aware of these issues, it's really not a big deal. It just means that when you're working on your texture maps, you should spend some time up-resing them in Photoshop. And I know that I'm going to paint additional details on these guys anyways in Photoshop, so again, it's not something that bothers me too much. So that's one issue. Another issue, let's take a look at how I've got these guys organized within the layers. I'll take a look at the head maps. So you can see within this layer group, I've got even more layer groups nested in here. So I have one for texture map, normal, occlusion, cavity, displacement, and bump. And same thing with the other groups. So you can see how these are all organized, and it's very clear where everything is. I'm also going to make sure that I take advantage of layers as much as possible and try and keep my editing as non-destructive as possible, so I don't have to go back and regenerate new maps if I decide to make a change later on. Um, so let's take a look at some of the displacement maps for, in particular, the eye. So here is the original displacement map that I created out of ZBrush from my mesh. And you can see, if I zoom in on the eyes here, that there's a really big issue. Now this is not ZBrush's fault, this is totally my fault, because I got a little overzealous when I was working on the inflating the facets of the eye. So you can see what happened is the polygons started to cross over each other because of the inflate brush, because I went overboard, and you get this horrible kind of bleed. And this is not going to look good when it's displaced at all. It's going to look horrible. So I went back and reworked the eye completely because I knew this issue is just not going to be fixable, and it's not easy to fix straight in Photoshop. So it really ended up taking me about 20 minutes to rework the eyes, and then I just generated new displacement maps for the eyes and brought them in and overlaid them as a layer here in Photoshop. And you can see these are a bit neater. The divisions between the facets are nice and clear. I don't have any sort of crossover bleeding. There is some sort of variation in light and dark colors overall, which is going to translate into kind of a lumpiness in the final displacement, but that's kind of what I want actually. I want something that looks organic and natural and not necessarily like a robot. So some of these lighter areas and darker areas that turn into lumps, I'm totally okay with that. I did the same thing with all the other maps for the eyes. So for instance, the texture map, I generated new texture maps for the eyes. And same with occlusion, cavity. For example, here's the cavity maps for the eyes, and these came out pretty well. So these are the original cavity maps, which are horrible and all kinds of crazy problems. Here's the new generated cavity map, looks a lot better. When it comes to normal mapping though, and I'll talk about this a little bit more, ZBrush normal maps, they're not the greatest in the world. I hate to say it. I love ZBrush, it's a great program. I spend most of my day in ZBrush, but when it comes to normal maps, even though this looks pretty good here in Photoshop, when it's rendered, they tend to look kind of soft or mushy. So generally speaking, if you're going to create normal maps for your model and you want the best possible normal maps that you can get, the workflow is actually is fairly intense to get a proper normal map out. So that's one of the issues that I sort of consider when I'm deciding whether I'm going to use normal maps or bump maps or some kind of combination. I prefer to use bump maps, and I usually go back and forth on this. But right now I'm kind of a fan of the bump map, and the reason is because the bump map, for one thing, they're very easy to use, they're easy to generate, and they're easy to edit. I can edit this in Photoshop, I can bring in new textures, paint over it. As you can see, if I expand the bump group, what you'll see is I actually have used layers here to sort of augment the existing bump map. So if we take a look at the head here, this is the original bump map that I generated in ZBrush. And I've overlaid sort of a variation of the cavity map, and I've done a little bit of sort of processing with some filters using like the chrome filter and unsharp mask to get these kinds of details right here, which here in Photoshop it almost looks like an error, but to me this is very reminiscent of the kind of noise that you're going to see on the surface of an actual insect. So I think it looks kind of cool, and I'll probably incorporate it into my specular maps as well. So it really depends on your own personal workflow whether you choose to use bump maps or normal maps, but one thing I do want to stress is that if you're going to use normal maps, you're going to have to take some time to do them right, because just straight out of ZBrush they're not going to give you exactly what you want. They'll give you pretty good, decent normal map bumping, but they're not going to be super high quality. So I wanted to discuss some of the things I did to fix the displacement issue with the eyes. This is something I should have done, or this process is something I should have done during the modeling process, but I think it just sort of slipped my mind. But it's always good to sort of see how you can fix problems, because that's what you spend most of your time doing when you're a CG artist, fixing problems. I'll turn off the texture display here and turn off polypaint so we can just see the eye geometry. From this side it looks like the eyes are just fine. It doesn't look like there's any issues at all. But if I rotate over to the other side, And I'll turn on in the display properties double-sided so we can see the backside. You see how we have the sort of negative inflate on the opposite side, and the polygons are kind of intersecting with each other. That's what's causing the displacement issue. These sort of intersecting, overlapping polygons. So to fix this, you can use a process called reprojecting the higher subdivision levels. So what I'll do is I'll go down to subdivision level 3, let's say, and I'll just smooth the geometry out. And once it's smoothed, it's basically relaxing the mesh. I'm going to go into the subtool palette, and in the project sub palette of the subtool palette, I'm going to press reproject higher subdivision levels, and ZBrush is basically going to go and take a look at the higher subdivision levels and reproject it onto the more relaxed geometry. Sometimes this takes a few tries to get it exactly right, and as you can see, there is going to be some repair that I have to do. So I will have to go in here and do some smoothing, some repairing, some reworking of this to get it right. But it's worth it in order to have a good displacement. Otherwise, it's kind of pointless to try and displace something that's not working. I spent some time working on this and reworked the eyes for a while. And this is the new version of the eyes. It's a little bit softer here in the model, but it's okay because it's still generated a much better displacement map. But if I look at the opposite side of the eyes, you don't see any more of that sort of overlapping geometry. So that's a good way to go about fixing these kinds of issues. Another process I wanted to demonstrate is how to generate, or one way to generate, a bump map in ZBrush. So if you notice, when I used a multi-map exporter, I created a normal map and a displacement map, but there was no bump map setting. So how do you go about doing that in ZBrush? I'll go down to the geometry subpalette, and at the moment I'm at subdivision level 1. So displacement maps are generated by taking a look at the lowest subdivision level, or I should say the current subdivision level, comparing it with the highest subdivision level, and then creating a difference map or a grayscale map that shows the difference between those two subdivision levels, so the amount of detail. The main purpose of a displacement map is to displace the silhouette, so that if I look at the highest subdivision level, so that in the final render, the silhouette of the details comes through. Some of this kind of detail right here that you're seeing. Like these kinds of things. The main purpose of the bump map is to create more of the fine details, some of these little tinier details that don't necessarily show up on the silhouette. So to create a bump map in ZBrush, what you can do is, instead of comparing the difference between the lowest subdivision level and the highest subdivision level, I can maybe go down to sort of a middle level, like maybe subdivision level 3. So I'm in the displacement map subpalette of the tool palette, and I'm going to turn on adaptive, smooth UV, and leave DP subpix at 2. Now, if I turn on an alpha here, you can see these buttons become available. This mode button, by the way, is very interesting, because what this mode button does is when I click the generate displacement map, it's going to create a true displacement map. But if I turn mode off, then it's going to create a bump map. Why is it set up this way? I have no idea. I'd love to see a giant button here that says make bump map, another giant button that says make displacement map. But instead you had to sort of, learn these sort of secrets of how ZBrush works in order to generate a bump map properly. So I'm going to make sure mode is off, and I will press create displacement map. And it's going to compare subdivision level 3 with the highest subdivision level and create the map based on that. Okay, so now it's finished creating the bump map, and it's placed the bump map in the displacement map preview. So to get this out of ZBrush, I'm going to press the clone displacement map, and that sends the bump map from the displacement map window over to the alpha palette, where I can select it and press export, and I'll save this and bring it in to my Photoshop file. And here I am in Photoshop. So this is the bump map that was generated, and so you can see it's a little bit more on the finer detail. I've done a little bit of editing on this to sort of to bring out some of those details. So I created brought in the cavity map and kind of lowered the opacity and placed it in multiply mode. I did a copy of these two, copy merged, and then added some filtering. I think I used unsharp mask and a chrome, and then just messed around with it, just sort of experimenting. So I've added a adjustment layer with levels. So I wanted to just compare for you the. So here's the bump map that was generated as ZBrush, and here's the displacement map that was generated out of ZBrush. So you can see there is a huge difference. So turning that mode button and using a different subdivision level makes a huge difference between bump and displacement. So just want to sort of illustrate that workflow because it's kind of a strange workflow. So this brings us to the end of Chapter 9, and we're all excited about that because the next chapter gets a little bit more fun when we start bringing these maps into Maya, and we're going to render with V-Ray, or I'm going to render with V-Ray. You're going to watch me render with V-Ray, and we'll talk about how I use Photoshop. So I go back to Photoshop and continue with the texturing process, but I'm also testing the shaders as I go. So that's how I sort of decide whether I need to do one thing or another, or improve a map, or change a map, or remake a map, or etc. So up next, Chapter 10.